Hey guys, coming at you with another mind-blowing video about math. This time we're talking about polygon similarity. First we're going to talk about polygon similarity is, then we're going to do another whopping 4 examples of different questions that can be asked involving polygon similarity. So let's take a look at the first one. Okay, so what are similar polygons? Two polygons with congruent angles, but the lengths of the sides are proportionally different. Proportional. So proportional means kind of two values, two fractions that are equal to each other type of thing. Ratios. So we want to think dilations here. The most similarity or all similarity is a result of dilation. All right. Let's take a look at that. So the first question here that's asked is, are these rectangles similar? Okay, they tell me they're rectangles. So by design they have to be similar, right? Maybe. I have equal angles, congruent angles, so that part's good, but do I have proportional parts? So I got this 42 here that got marked off. So what I did is I set up the proportion here ahead of time to save some time. So I went from 35 to 42. So I went from this triangle on this rectangle, rectangle 1, rectangle 2. So I went from rectangle 1 to rectangle 2 with 35 to 42. Then I did it with 20 to 18. Now, typically I like to try to reduce these. I think that's the easiest way to tell. So that's the way I'm going to do it. Well, I could reduce this by 7. So this becomes 6 over 7. I can't reduce this by 7. So already I know it's not similar. The best maybe I could do is reduce it by 2. So 10 over 9. Okay, not similar. Next. Here, okay, on the other hand, I have my rectangles. The angles are congruent. We have 90 degrees all the way around. So now, are my sides similar? So I'm going to do the same thing I did last time. Label that 1 and that 2. I'm going to go from 1 to 2. So I'll go from 25 to 10. Then from 40 to 16. So I don't have to try all 4 sides. That would be redundant, wouldn't it? Because their opposite sides are congruent here. So let's see what my trusty calculator says about this. So 25 over 10 reduces to 5 over 2. Well, let's see what happens with this one. 40 over 16 also reduces to 5 over 2. So that means yes. Okay, they are similar. Yes, similar. Okay, it's not like this is an English class or something. Alright, so that's how we answer that question. Alright, next. So there's a couple of different questions we ask, and that involves solving for x. So you have to make the statement, or the question needs to make the statement that the triangles, or polygons, I keep saying triangles, the polygons are similar. You can't do this otherwise because you don't know it's proportional. So that statement needs to be made. The polygons are similar, so solve for x. Alright, how am I going to do this? Let's take a look. I'm going to be straightforward. This sometimes requires a bit of guessing. I can tell you what I don't want to do. I see this decimal here, and I want to avoid that. So what I notice is that this is the long side, and this is the long side of that polygon. It looks to me like they kind of flipped them over. So with that being the case, I'm going to guess, or I'm going to assume, with a good assumption, that these two parts here are proportional, or corresponding. So I'm going to say x minus 5 over 42. Then I'm going to say that this is slightly less slanted than this one. This is my quality artwork here. And so I'm going to match that one up with this. 5 over 30. Well, the good news is I can reduce that, and I'm going to, because my number just got a whole lot smaller. I don't know about you guys, but even though I have my trusty calculator, if I could avoid multiplying big numbers, I'm going to do that. So now I'm going to cross multiply. So this is going to head to the 1, and the 6 is going to multiply the x minus 5. 6 x minus 5 equals 42. Now I'm going to distribute that 6 equals 42. I'm going to add 30. So that's going to become 72 equals 6x. I'm going to divide by 6 to undo that multiplication. And 72 divides 6. And I got 12. Okay, now I'm going to put a warning label on this. I use this specific program to generate these questions. It's very good at making questions that come up with whole numbers. That does not mean that proportionality has to always result in a whole number x. As a result of that, you got to be careful, because if you get a decimal and the answer is supposed to be a decimal, you really have to double check that you picked the right sides. Okay, let's try it again. So this one has two what looks like parallelograms, and it tells me that they're similar. So I could set up another proportion. They only gave me, thankfully, 2 sets of sides here. So I have to figure out what goes where. Well, this is on like the short slanted side, and the 30 is on the short slanted side. So they're corresponding. There's a relationship there. So I'm going to say 30 over 2x plus 3 equals, since I went from this guy to that guy, I'm going to have to do that again. 48 to 40. I have to stay consistent with the direction, just like I did on the last question. I started at 1 to here. I can't flip that. If I go from 1 to 2 on one side of the equal sign, I cannot go from 2 to 1 on the other. If I do that, I'm going to get the problem wrong. Now, once again, I notice that these guys are reducible, and I am taking full advantage of that. So let's see what that reduces to. And notice, right, I'm still using the calculator to reduce, but now I can use smaller numbers, or I might not need the calculator any further. So I'm going to cross multiply again. That's going to go to the 6. So I have 6 is 2x. Let me write it over here so I have a little bit more room. 6 is 2x plus 3. Maybe I don't have that much room there. So I'm going to go back to here. 6 is 2x plus 3 equals 5 times 30 is 150. Now I'm going to distribute. So 12x plus 18 equals 150. Okay. Now I'm going to subtract 18. And I have 12x equals 150 minus 18 gives me 132. I divide by 12. And x is going to equal, see, divide by 12, 11. And there we go. All right, guys. That's the video on triangle polygon similarity. And hopefully you guys found this video helpful.